This session is about exception handling and regular expressions. So these two concepts are two small concepts, but very powerful concepts. So in the reason that we need to do exception handling and the reason that we do regular expressions, we will look at that, and then we will also write some code, some demo code to do these things, and then we'll also see the real world examples for these two stuff. Okay, so let us get started. So so in computers, so exception is something that you don't expect, such as say for example you're trying to open a file and file doesn't exist. What happens is the problem with these exceptions, in especially in scripting language like Python, or any other language, what happens is once you encounter an exception, the whole execution section is blocked. That means if you are running it as a process, if there is an exception, the process gets hung or it gets crashed. So that is also called as system crash. Okay, so let us look at. We have already looked at some exceptions in our previous classes. So let us get started. Okay, let me give some demo. So exceptions, when they occur, they look like this. For example, a is equal to 10, and what I'm trying to do is if is equal to 19. Okay, so as we saw, if is a keyword in Python, and it cannot be used for variables, and that is why it is telling that we have encountered syntax error, and it just puts out where is the error and other information. Okay, so let us try to open a file which doesn't exist. Okay, let me copy the code from yesterday's session. Okay, so here this is also one of the exceptions. It is telling that JSON is not defined, because JSON is a library and we had to import it. So if it is not visible, if the code is imported code is not visible for this section, that is at this execution point, it says that I am unable to find this library, and it doesn't know if it's a library or not, because once we import it, it becomes an object, and we just assign that object to an variable, and we just use it as a simple object. Okay, so this is one of the exception. So let us see. I'm going to just simply change a file name which doesn't exist. Okay, so this is just a variable. I'm just storing it. So let us see if we try to open. So we can see that we got an exception saying that file not found error. Okay, so you can also look at there is a pattern in all this exception. So the pattern is like, okay, it says traceback, and then it gives some file name, and it also gives what kind of error it is. In case you are running it in a sequence, or in a file, or in a script, or in a code, what happens is the program gets halted. So let us try to do that. Okay, so what I'm going to do is I'm going to get out of this interpreter and modify this file name, because that file name doesn't exist. So I'm going to run that file for this COVID stats. Okay, it got open. Is there a file? Okay, I didn't save it. All right. So you can see that we're doing a lot of operations below this line. So we have nested for loops that we did yesterday. What is happening is at line number 8, we are just defining a variable for file name, and then we are sending that variable to a function called as open, and open, it tries to open a file which is present on the disk, and It says I cannot find any directory called as a COVID statewise sample.json underscore. So this doesn't exist. And after saying that, it just exits, and it doesn't do any kind of execution for all of the lines that is below that. So this is what I was telling, that it just halts and it gives this traceback. So why it is called as traceback, I will tell you in a minute. So the format is like this. It tells traceback, and it also tells the function calls. That means what are the functions that so far that is in its program stack, and it dumps all the stack frames. I'll tell you about stack frames, and then it tells what is the error. So coming about talking about traceback, this is coming from languages like C++ and Java. So traceback is nothing but to encounter this error, we might have made a function call, or this could have been called from another file or another module or a package. So there is a certain way of execution in internally that all the programs are executed. So what happens is, for every execution, we just push an instruction, or all the functions calls, or module calls. What we do is, we put it as a frame into a stack. That means, say if you're calling a function called as a, and a calls b and b calls c, we put a, and then on top of that we put b, and then on top of that we stack up c. So when if there is a problem at c, say it's unable to load the file, or if it is unable to find the file, so what it does is, it is called as stack unwinding. So that terminology is coming from other languages like C, C++. So the program just dumps all the frames that is existing in stack. That means A, B, and C in a reverse order. That means C first, and then C calls B. C is getting called by B, and B is getting called by A. So it tells us from where this execution has started. It is possible that we are calling C from another module called as D. So if the problem appears in C, so we know that there is a certain path. So it is coming from either D or either B. So that is how this stack traces or stack frames work. So that is how the instructions are stored on function calls are stored inside the program execution flow, and that is dumped as traceback. So that is why it is called as traceback, because we are able to trace back from the callers, what are the callers, and then where the exception happened. So this is called as exception because we do not it's an unexpected unexpected output from an program. So that is why it's called as an exception, and this is traceback, and this is called traceback because it just dumps all the stack frames. So that is about exception. Okay, now the problem here is, obviously, is, say if you're running a software which is maybe it is polling different websites, and then it is collecting some information, and then it is maybe it is doing some kind of reporting. So if we have this kind of flow, say for example, one of the websites is down. So what happens is, if it is not able to find that website, so it will just give a trace back, or it will just throw an exception saying that, okay, I'm not able to find that website, and all the websites after that it won't go to that website and fetch the information, because the program halts there. So we are bound to face, because of one error, so all the other executions are halted. So this is the main problem, and this is why we need to handle those exceptions. So why do we need to handle those exceptions? Because in order to continue with the rest of the program execution part. All right. So that was about the effects of exception. And then coming to how do we handle it, and it is simple. What we do is we put code inside something called as try and accept. So this idea is coming from C, C++, and Java. So what we do is, say for example, I have some code which I suspect that this might go wrong. So what I do is I simply put that section of code in try block. So this is also anything which starts from ends with colon. That means it tells that there is a beginning of block below that colon. So what we do is I will just try to put all of this. There is 5 lines of code here, or 6 lines of code, and then accept. Then I'll just print for our readability purpose. So continuing with code. Okay. We will encounter some other error, but we will just see. Okay. So this particular exception, that is the file was not found, this file is not there, and we're trying to open. So that there was an exception here before, and then we have handled it using try and accept block. So it's like, okay, try this code, try all this code. If there is some exception, catch it here. Okay, catch it here and handle it. So that is what this statement does. All right, except. Now the another exception that is coming is, it is coming from this. That is because this doesn't know, since there was an error here, it did not execute 11, 12, and 13 until 14. So this code is not aware of this variable. So that is why it is telling that, okay, I'm not able to find the find this variable. So that is why it tells name error. So there are standard list of exceptions. So there can be a lot of exceptions. I'll just show you on its on a website. Okay, so these are built-in exceptions. So exceptions could be of various types. That is, it could be coming from arithmetic operations, such as like if you're trying to divide a number by 0, that is an exception because it's not defined. And then buffer error, when we try to access a buffer, or buffer is not present, or something like that. So as and when you do a lot of programs, you'll come to know that. Okay, say I will try to divide 2 by 0. So it is telling that it's a 0 division error. And then we saw about OS errors, such as file is not present. And there are several other errors. So the common errors that you might be facing is like, okay, I have a list 2, 3, 4, 5, 6. So this is the list, and then what I'm doing is I'm going to access few elements. Okay, so I have a first element which is indexed by 0, and then I have this element, that is 1, 2, 3, 4, and fifth element, so that is fourth. So that's the last element. So let me try to access the next one. So it's telling that, okay, this is an index error. That means you are trying to access some other index which is out of range. So that is one of the common errors that you might face, especially when you're trying to access a list in a for loop, and you're trying to access next element, or you're trying to sort something. So such programs you'll face this kind of error. Okay, so in order to handle this, you need to put that particular block inside try accept, and then you need to handle it. So it is also possible that you can write your own code to handle these exceptions without try error block, try except block. For example, I am going to handle this particular error that we faced, that is name error. State-wise data is not defined. So in case if I have to handle it manually, what I do is, okay, well, it is telling that name error, this is not defined. So what I'm going to do is, either I can use this state-wise data variable and initialize it to um, an empty map or a dictionary, and then coming here it finds no items and it just goes away. Also, I can handle even this without the try error, a try except block, such as I can remove this, and then okay, so I can write some defensive code. This is called as defensive code. That means if you do something and if you do something, or if you're calling a function, and then what you do is you kind of write if else conditions, whether if it's a valid output or not. So if file descriptor do all of these things, or else say print unable to find the file. Okay, so let us just file not found error. If okay, let us try to print this value and just see what is it, and then we can handle that. File descriptor file descriptor is not none. Do this. Okay, the exception is being thrown inside open, so we have to write code inside open. So usually in such cases there is no other way other than to try and accept, because that exception is coming from inside this. That means I have to go to that particular function and then write exception here. So it is designed in such a way that it will always throw an exception. Okay, so that we cannot handle using if else condition. Okay, so this I have to put in try except block. Okay, but anyways, so in case if you have anything that is in your control, that means if you have written a function and it is throwing some unexpected output, then either you can write if else condition and then handle it. The problem with if else condition is it can grow, there can be many different conditions. Say if you have a function which is returning various written values, say -1, -2, and then for every error it is returning different values, and if you have to handle it for every kind of written values, then it's really difficult. So this whole idea of exception was designed in order to address this particular problem, that instead of returning values and handling it, so that is the traditional way that we do in languages such as C++. In fact, C++ has exception handling, but in embedded systems we do not, we avoid using try and try catch block. That is because when the stack unwinding happens, it leads to unnecessary problems. So that is why we try to avoid it, but there is a feature in C++ as well. Okay, So that was about exception and how to handle it. So how do we find exceptions? How do we find functions that can throw exceptions? Is because it's not because is like, okay, if there is a critical code such as opening a file and you're writing something to database, or you are trying to access a list of something, and you're trying to do some extra operations on top of it, not just reading, also you're trying to write. And maybe you're creating a tuple inside, and then you're trying to access write into a tuple, modify the values of tuple. On such cases, you kind of identify this is my critical part of code, and then you try to put it in the try except block. Okay, so that is how you kind of identify it. So the reason that you need to write try except block is because if you do not write it, the program execution will halt. Okay, so the neat way of handling it is like you put it in a try block, uh, and then you will kind of handle it like this. Okay, and then what you do is you kind of print log, and then maybe in order to debug, you can check the logs or print statements, and then you can find out, okay, you can fix those errors if it is fixable errors. Okay, if it is in your control. Okay, that was about exceptions. So that is how you do the exception handling. So in our uh, problem that we discussed yesterday, so we can um, what you can do is you can try to access one of the states called as Chalukya, which is not there in that JSON, and it will lead to a error called as key error. That means I'm unable to find this key in the dictionary. And then instead of halting the whole execution, what you can do is you can tell back the user that, okay, this state called as Chalukya is not present, and continue with the rest of the execution. So that is an exercise from exception part. So the syntax is simple. So syntax is actually there is you can do more with try except block. That means you can also, there are a few more keywords that you can use, such as finally, and then there is also else. uh, Try except is like a simple version of it. So you can also use else statement with try, and also you can use there is a keyword called as finally, and which always it gets executed. So that you will learn when you are trying to solve the problems. And usually this is the syntax. Put the statements which are like suspicious, and then which are like susceptible to throw some kind of errors, and and then handle it in the except block. So this is a generic way of handling. For example, you can also handle it using particular or specific exceptions. For example, I can hand so I know that this is going to throw file not found error. So what I'm going to do is I'm going to accept exception. This is an exception. So this exception, handle it as except this handle, this one, and then I can also put this is a generic exception. The reason is that in this code I can see that there could be multiple exceptions. One is while opening file, and another is maybe while loading JSON. That particular JSON format is not in a dictionary, or it's not in the right format. So JSON can also throw some exceptions that we will see. So this code has potential of raising maybe two exceptions as of now. So we will find more exceptions, and we'll try to write more code. Okay, so except here. So I'm going to put a print statement just to identify this. Continue with excepts. Except. now you can see that it is printing except file not found error, because we are catching a specific exception, that is file not found error. So you can write code in such a way that, okay, if this exception occurs, handle it like this, and if this exception occurs, handle like this. So let me try to give an I'll give a file which is existing, but I'm going to change some things, which will lead to which will lead to an exception which gets thrown by json.load. Okay, so where is our file? Okay, here. So I'm going to remove one of the braces. Okay, and then I'm going to run this. Okay, so there was an exception here, so let me just delete these two lines of code and then look at the exception, and then it is easy to handle now. Okay, now there is a specific exception for this which is getting thrown at json.load. It is telling that, okay, I'm expecting some kind of delimiter in such and such a line, and this is an exception. Okay, so this is not handled, so I'm only specifically handling file not found error, and everything else gets in just in case if you do not find any of the except block that is handling it. So what I'm trying to do is I'm just everything else handle it here. Okay, so the problem, if you only use except, yes, it will catch all the exceptions, but you won't be able to handle it differently. For example, this is an exception. So what I'm going to do is I'm just copying this and put it here. Okay, and then accept JSON error. So accept all. Okay, I haven't saved the file. Okay, now it is telling, okay, it's a JSON error. Okay, so the reason that we are using dotted notation is because we do not have direct access to JSON decode error. This is the exception, but in order to access that, that is present inside the JSON module, JSON, and then there is another module, decoder, and inside that there is a JSON decode error. So this is the hierarchy. So either you kind of import this module here, somewhere here, just to make it visible. Okay, there is another way to handle from this decoder import. Now I can skip all this and simply use JSON decode. So yeah, it's working. So the overall idea here is this exception, that those exceptions are also an object inside Python, and I need to import that module, and then that module will get visible in this program flow, and then I can use it directly. Okay, so that is how you kind of handle exceptions. So you can kind of find code which is critical, and then you know what, if this file is not found, do this. Maybe here you have some code, something like, okay, if this is not the file, you pick up another file, or something like that. So you can write code here, further here, and then if that JSON is not right JSON, so maybe you send a mail to administrator or someone who is sending that file. That means telling that, okay, JSON is not in the right format. Okay, so that particular code can be called after exception, after this is handled, and we just move ahead with the rest of the program execution. So that is about exceptions and how do we handle specific exceptions and stuff like that. Okay, so any questions so far on exception handling? Any question that is like basic question or anything that you didn't understand?
Digant, what is the difference between this except and else?
Okay,
No, one more thing you mentioned, right?
right.
We can
Okay,
use it.
okay. um, you can also there are different keywords. That means we'll just look at this. Okay. So in order to um, find out what else does, so this is how you do find it out. And okay. So idea here is either you if this doesn't occur, then you can do this. Okay, that means and there is also finally keyword. This gets executed no matter what. Executed. Okay. Okay, so let us run this. What am I missing? Finally. Accept. Oh, all right. Okay. Let's try to execute this. Is there any problem? Try and then else. Except this else and file. Okay, let me look at the syntax. All right. This else should be paired with try. That means to dt. Give me a minute. All right. Okay. Okay. All right. So what else does is if none of the exception occur. Okay. If none of the exception occur, do this. Okay. All right. So let us try that. Uh, where is this paired? Let me figure that out. Okay, finally is like whatever happens, always this part of code gets executed always, and then we find out what is try. Else. If this doesn't occur, maybe I'll put it here.
Yeah, that has to go below file not found, I guess. Yeah.
Right, yeah. This else. Okay. this is the right form. Yeah, yeah. That was about struggling with the syntax. Yeah, but the idea is you can figure out the syntax. Um, okay. If none of this exception occur, then do this. Let us try to simulate that in else. Mm, file not error is not found, and then JSON decode error. Okay. I'll just correct this. JSON. And then let me save this file as well. Okay. Okay, here it is. Okay. In this part, so we have that means we're trying to catch some kind of error in this part. So if this file is not found, you do this. If some other exception occur, do this. Else, that means if there are no absolutely there are no exceptions, then do this. Okay. So the syntax is because we generally don't use else with try catch or try except statements. That is why I struggled a little bit with syntax. Okay. So this tells that, okay, if this doesn't occur, just do this. Okay. So usually that use case can be handled outside the try block, so that is why we usually don't use this, but that is the syntax. So you use try must always follow with at least one except no, one except block, and then this two is they're optional. Else, if there are no exceptions, and finally is anything that means whatever is the case, do this. That means, for example, if you want to clean up something after this, say for example, if you want to delete JSON file, it doesn't matter if it exists or not. Or maybe you're cleaning up some memory or any temporary files. Such things can be done in finally block. So that is about exceptions. So right. So any questions here in except and try except block? Okay. So let us move to next next topic, that is regular expressions. Regular expressions is actually quite powerful, and it's quite vast. That means you can write a lot of complicated regular expressions to find out some text. So what are regular expressions? For example, if you see a tree, you can identify it as a tree because it has a certain structure. That means it has a trunk, and it has branches, and it has leaves. So that is how we say that it is a tree. And say if you look at a home, you can identify that as a home. That is because it has walls and windows and stuff like that. So anything that we recognize has a certain pattern. That is why we kind of recognize that as a that is an object. So similarly, when we are doing text processing, there could be use cases where you want to specifically extract some data which has a certain pattern. For example, if you have a big log file, and if you want to extract, say, a particular statement that has a particular IP address. So you know that IP address has this kind of pattern. That means it has 4 digits separated by dots, and then you can write some irregular expressions, and you can find out only those lines. And also, for example, usually occurring is like date. So once you see this, you already know that this is an IP address, this is an date, this is a date for. And then there are a lot of things. For example, if you look at this, you can make out that, okay, this is a timestamp. And if you look at this, you can tell that, okay, this is adding some time zone value here. And then if you look at this statement, you can also maybe guess. If you're from a technical background, you can say that, okay, this is a get command that is sent on HTTP, and this is a this is the written value that is it is giving. And then the files are having certain extensions, and then file name dot something, so that has some pattern. So all these kind of patterns that we see in day-to-day life, this can be actually written in form of a generic way of extracting. And then we can find those values and then make use of those. So actually, you're unknowingly we are using it already. So for example, if you go to Linux terminal, and I want to find all the in this code. So in this code folder, I want to find all the functions. So what is the pattern of functions? Functions have something called as def. It's a keyword, and followed by at least one space. So if I just say grep def and search everything, so I get all the functions. Okay. So also there is one more. So this is not a function here. So I want to further filter it. So what I do is, okay, give me all the functions, and functions are starting with def. That means it should start with def. So I use this character that it tells that it is starting with. So it starts with is indicated as this. So if any line starts with this, so find those lines. Okay. So this is how we find things in Linux. So this is an example for regular expression. That means I am finding all the lines which are starting with def, def. Okay. And has at least one space. Okay. So that is an example. So let us look at various other examples. Say for example, I'll take let us jump back to interpreter. Okay. I will do something called as this is my IP address. Okay. 20.20.20.1. So we have a module called as RE. RE stands for regular expressions. Import RE. Okay. So what I can do is I can try to search a particular IP address in this string. So in order to find out the functions inside that, we know that you can either use dir keyword, or you can look up online and then find out, okay, how either you can match, or you can match and then return it as a variable. Okay. So let us just my regular expression regex, try to build some regular expression. So as we see that this is a text which are having certain numbers here. So this is an IP address because it has 4 numbers and separated by dots. So that is one of the patterns that we recognize IP address. So so for example, so you don't take it as is. For example, this is not an IP address because it doesn't come under the range of IP address, but just to simplify the problem. So IP address is having 4 digits and separated by dot. So in order to write regular expressions, we can write something like we can put it as a variable, and then say digits are in order to find digits, we use d, and then just to make sure that this d is not a simple character or part of string, this is called as this back slash is called as escape character, and I need to escape that. It tells the compiler that okay, this is not a d character d, it is something else that is to do with some other module. So do not read that d as character. So that is what it tells. Okay. So D stands for digit. It's for single digit. Actually, you can for two digits you can use this. So we're just trying to simplify, but let us try to do this. So I have two digits. I have two more digits. I have two more digits. I have two more digits. Okay. So this is my regex. So in order to find that, what you do is re dot I think the my regex, I think the function syntax is correct. Okay. Okay, this last one has only one digit. Okay, so without even looking at the knowing the exact IP address, I'm able to search this particular string inside this complete string. So that is because I am trying to write a regular expression here, telling that okay, if this is the format, find that. Okay, so that is about IP address. In fact, you can write you can write this instead of using two slash ds, you can also write something like place. So this is actually vast, as and when you kind of want to recognize some pattern, what you do is you search it online and and find out how to write a regular expressions for particular values. For example, if you want to find out timestamps, there is a particular regular expressions that you can write. So let us search. Okay, now even if I'm using only d only one time, so plus tells that either one or more. So that is uh, one of the ways to find out more numbers. For example, actually this is a wrong regular expression for an IP address. Say this is not an IP address. Okay, because IP address must have certain range, and it should not any digit should not exceed 255. But this also matches this one. So that means the regular expression is wrong, but your statement is right, but the regular expression is wrong. So in order to actually IP address regular expression is slightly complicated. You can look up online, because you have to match with you have to write a regular expression in such a way that okay, this digit should not exceed more than 255, and it should be in this range, and also maybe you're writing a regular expression which matches IPv6 as well as IPv4, so that becomes much more complicated. But for simplicity, this is how we try to use regular expressions and match it. Okay, and then once it is matched, you can take that line and then maybe filter it, and then use it for your analysis or your further processing. So usually if you want to extract some data out of a log file, say for example there is a DDoS attack, distributed system attack on your system, and there are continuously ping requests that are coming, and if you look at network logs, you can see that okay, there are so many ping requests that are coming, and then you can also find out you can write a regular expressions in order to find it IP addresses, and then again, on top of that, you can filter IP addresses that are out of your network, and then you can filter all those and put a statement in your routing table that, okay, if this comes, just drop the packets kind of analysis. So that is one thing. And also another use case is like, you want to find out, so there is a system which dumps logs all the time, and then there is a customer reports problem on a certain day and certain time, telling that, okay, I'm unable to do certain operations. Say my wi-fi is not getting connected, and it just stops. There is no internet access, but I'm able to see the signal. Okay, so in order to do that, what people do is they extract the logs, and then maybe you want to extract logs on certain day, say for example 31st October, between 31st October and 1st November, at 11 o'clock, around 11 o'clock, then you kind of write a regular expressions in order to match that particular date and time, and then you can simply extract the logs, and then that becomes your now you have narrowed down your problem space, and then you can work on top of that. So there are regular expression is vast, and now regular expressions are almost standard. That means if you write a regular expression in Perl, it is almost equivalent to Python, and there is always standardization happening, and people are trying to write languages in such a way that regular expressions are can be ported from one language to another language. But there could be some problems which are here and there, and but mostly it is standardized. That means if you see a regular expression, you can use the same regular expressions in another language as well. Okay, so that is about regular expressions. So you can also check, there's a big list, like what are regular expressions, and how do you parse, how do you catch spaces, and how do you catch numbers, how do you catch certain characters. So all this stuff, it depends case by case. And whenever you encounter such cases, you write a regular expression. The best way to do is you search online and find a regular expression, and then try it out on your terminal, and then you modify that and use that. Okay, the idea is you don't have to reinvent the wheel. So idea is you must understand what you're doing. Say if you get an IP address, regular expressions, once you get that, you try to understand what it is, and then verify that with various IP addresses, and then make sure that, okay, it is working, and then you use it. So for simple regular expressions, you can write it straight away. Okay, so that was about regular expressions and its uses. Okay, so I'll post a assignment on exceptions as well as regular expressions, and then if you have any questions, you can ask now.